Okay, welcome chemistry class. Today we're talking about the scientific method. This is something you guys have seen over and over again, probably since elementary school, even maybe before then. Um, you know the basic steps. Sometimes we know where we're going and we have kind of end goal in mind. Other times we've kind of got a basic framework to follow, but we're not sure exactly where we're going to end up. So you'll see both types of labs in this class. Hopefully a little bit more of this than the kind of end goal in mind. This is more fun, but we'll find out. So, in order, first off, you have to have a problem. Okay, so what's the point? Why are we doing this? Where are we going? What's the end goal? So that's the first step. Then you really should do some background research, especially out in the real world. So what's already known about your problem? What are the chemicals you're going to be using? How do they react? Is it safe to do what you're going to do? You know, we don't want to cause an explosion or set off the sprinklers or anything like that. A lot of times you'll see MSDS form. So here's an MSDS form I looked up on the internet for water. So nothing hardcore. So you can access these online. We also have a book with a bunch of these in them in the prep room. So there's lots of great information here. You can see name, what kind of hazardous information, like, is it dangerous? It's going to kill you. What to do if you, put it in your eye, inhale the stuff. For water would be kind of interesting. Lots of safety data here. And then you get to some good physical and chemical properties. This is going to tell you what it does, kind of what to expect when you're dealing with it. Also, something to really look for is solubility. Can you make a solution with this? Lots of different things. So, let's go back to the PowerPoint. Okay, so we've done our background research, we figured out what we're going to do, and now it's time to come up with a guess, really. An educated guess is a lot of what this is called, on what you expect to happen. Hopefully we've done a good job in the research and we have a good hypothesis that we can test, but if our hypothesis is wrong, no big deal. Happens all the time. Sometimes a lot of the great discoveries were from accidents rather than what was expected. After you've got your hypothesis, let's get some procedures. What are you going to do? A lot of times this is like a step-by-step set of directions. It's more of a formulaic lab. Other times it's okay, a plan of what you're going to do. Even kind of flow chart like this lady has. Okay, if I get this, then I'm going to go over here, go this way, go that way. Kind of some more flexibility. Some of the labs will have a flow chart type of procedure, not step-by-step. So now you've done your procedures, you've actually carried out the experiment. So what happened? You probably have some handwritten notes that you jotted down as you were doing it. Maybe you've gone an extra mile, made a chart of the data and kind of organized things, and maybe eventually you'll make some sort of graph. This is a pretty simple one, but you get the general idea. Okay, so now it's time to actually do kind of the thinking part and the conclusions. So all this data and observations that you've been doing, what does it all mean? What's the end goal? How things turn out? So it's a good idea to come back, take a look at your hypothesis. Okay, so was your hypothesis supported, or was it rejected? Was your guess right or wrong, basically? We'll talk a little bit why we don't use the term proved later on, but for right now, was it supported or rejected? And then also a good idea to come back and take a look at the problem. So your problem, you got an end goal in mind, right? There's a purpose for this. So did you accomplish your purpose? Do we need to go back, do something else? So that's basics of the scientific method. If you have any questions, talk to me in class. But that's it for now. Goodbye.